Hello and welcome. I'm McKenna Allen, founder and president of Wild Ones Greater Indianapolis chapter. We're so glad you're joining us today. My chapter works to connect people and native plants here in central Indiana, and I'm excited to be a part of tonight's program. Before we get started, just a couple of quick notes. This webinar is hosted on YouTube Live, so feel free to introduce yourself in the chat. If you'd rather not see the chat, you can switch to full screen mode. Closed captions are available in your settings, and remember, you can pause or rewind anytime with the player controls. And if you enjoyed tonight's program, remember to like the video and subscribe to our channel. For those of you who are new to Wild Ones, we are a nonprofit membership organization devoted to promoting native landscapes through education, advocacy, and collaborative action. Our mission comes to life through the grassroots efforts of local Wild Ones chapters, along with national programs and resources like this webinar. If you are not a Wild Ones member, we hope you join us in helping native plants and natural landscapes thrive in every community. It's now my honor to introduce today's speaker. Doug Tallamy is an entomologist, author, and one of the clearest voices in the native plant movement. His books have inspired thousands, myself included, to transform their yards into habitat. He is also a lifetime honorary director of Wild Ones. Please join me in welcoming Doug Tallamy.
Thank you, McKenna. We're going to talk about what I call How Can I Help? It's the title of my latest book, Saving Nature with Your Yard. But before we do that, let me just remind you, we humans are evolutionary guests on this planet, and our stay here is provisional. If we destroy our life support systems, our residency is going to be a short one. Who's going to protect nature? People wonder. It's got to be everybody. I think it's everybody's responsibility because every single person on the planet depends entirely on the quality of local ecosystems. Unfortunately, more and more people are accepting this responsibility, but they have lots of questions, and many of those people send those questions to me. Now, I have written books and I give talks, and these are largely questions from people who have read those books and have heard the talks, and they still have really good questions. So I thought I would put them together, put the answers together into what we call How Can I Help? 499 questions about saving nature with your yard. One of the questions is, why is it 499 questions and not 500? I actually submitted a lot more than that to Timber Press, but they started to weed them out, and it turned out to be 499. So the first question that I'm going to deal with, and I get it quite a bit, is what got me interested in conservation? And there actually is a story attached to that. When I was in third grade, we moved to a new house in Berkeley Heights, New Jersey, and our house was built on a circle, and they built the houses from left to right, so the lot to the left of us was undeveloped. We lived in a development called oak parks because oaks are what they cut down in order to make the development. But there was a little pond on that lot next to us, and I used to go over to that pond every day and see what was happening. It looked much like this, and in the spring, this is what was happening. Toads came and started to sing. I do not remember whether I knew they were males or not, but I do remember that these singers hugged bigger toads that came along. I thought that was nice. And they kept hugging them while they were laying eggs. And of course, this is external fertilization. This is the male, and he's fertilizing the eggs as they come out. And then I got to watch metamorphosis. I got to watch the eggs hatch. I got to watch the pollywogs swimming around. I got to watch the hind legs pop out and the front legs pop out. I got to watch the tail shorten and then just about disappear. This was an exciting time because I wanted to be at that pond when all the little guys hopped out and started their terrestrial life. And they really are little when that happens. And I was there. I was hunkered down next to the pond. And that is when, oh, there I was right there. That's not really me. That's when the bulldozer came and buried that pond, buried all my little toads. I ran away, so it didn't bury me, but it did make an impression on me. And the impression was pretty much the accepted wisdom of the day. We have to save nature before people destroy it. The problem with that is that very few of us have the opportunity to save pristine habitat, but all of us have the opportunity to restore what has been lost. We have to move beyond conservation and start to embrace restoration. I could have gone right across to my backyard and dug another pond, could have saved so many of the things that lived in that pond, but it never occurred to me. And my parents probably would have helped me, but it didn't occur to them either. So it was a lost opportunity. Okay, another question I get is why can't insects adapt quickly to non-native plants? And that's a good question because yeah, I talk all the time about non-native plants being unable to support most of our local insects. But we do know that when we spray a field, for example, in just a few generations, insects develop insecticide resistance. So if they can develop resistance to insecticide, why can't they adapt to new plants? Well, when you spray up a field, there actually is resistance, some level of resistance that already exists in the population of the insect you're spraying. So we'll call them these orange guys here. You kill everybody else, but you don't kill the orange guys. And the next generation is going to have a lot more orange guys. And then the next generation is going to be mostly orange until finally everybody is resistant. And that doesn't take very long to happen. The problem is, well, that happens so quickly because no new traits have to appear. You really don't need evolution to occur for this population to become resistant to the insecticide. That's not true when you're talking about adaptations that have to occur for an insect to use a new host plant. There's all kinds of behavioral adaptations that have to change. So let's consider what those are so you can see how hard it actually is. The first thing that has to happen is an insect, and we'll call it a red-spotted purple here, has to recognize this new plant as a potential host plant. And it does that with its antennae. It's flying around. There's hundreds of plants below it, and it's got to pick out this new plant and say, oh, that's a potential host plant. For that to happen, there have to be changes. There have to be genetic changes, mutations in the receptors on her antennae. So that's one change that has to happen. Then she's going to land on this plant, and she's going to taste it again with receptors on her tarsi. So we have to have simultaneous mutations in the receptors on her tarsi to say this is an acceptable host plant. And finally, before she actually lays an egg, there are receptors on her ovipositor. She's actually tasting the leaf a final time to make sure she is putting that egg in the right place. So you have to have simultaneous changes in those receptors as well. Now she's laid the egg. The egg is going to hatch. The first thing that happens is the caterpillar eats the egg mass or the egg shell because there's a lot of protein in that. But then the caterpillar has to start eating the leaf, and this is going to take more genetic changes. The caterpillar has to recognize that leaf as a potential host plant. So the sensors in its taste buds essentially have to accept it, and then the physiology within its alimentary canal has to be able to detoxify the novel chemicals that that insect is going to encounter. So there's got to be a lot of adaptations and inside the caterpillar as well. So all those things have to happen for an insect to adapt a new host plant. They've got to be able to detect that plant among an array of other plants, accept the chemical signals on the leaf waxes of that plant, both with the tarsi and the ovipositor. Then the caterpillar has to accept the new taste of the plant and be physiologically able to detoxify that plant's defensive chemistry. That's called a host switch, and it does happen, but not very often. It's really hard for all those things to line up at once. I'm going to use the monarch butterfly as an example. Well, of course, we know monarchs are specialists on milkweeds. Well, black swallowwort is a plant in milkweed lineage. It's not an Asclepias, but it is related to milkweeds. And it smells like a milkweed, and the leaf waxes smell like a milkweed. So the monarch is attracted to this plant mistakenly. It will land on it, and its tarsi say, "Yup, this is milkweed." It actually lays an egg on it, and that's where the whole system breaks down because the monarch caterpillars that actually eat black swallowwort die. They cannot detoxify it. Now, black swallowwort was introduced in 1854, so 170 years later, after opportunities all that time, the monarch is still unable to use that black swallowwort as a host plant. Just to show you how hard it is for all those adaptations to happen. Okay, related question. You claim it takes thousands of years of error for insects to adapt to new host plants, but some other entomologists disagree and point to several species of butterflies that now breed successfully on non-native plants. How do you explain that? Well, I explain it this way. There's two ways that insects adapt to a new plant, or I should say use a new plant. One is host switching. That's what I just described. The other one is host range expansion. And most of the cases where native insects are using non-native plants are host range expansion. They're not really host switches. And the key about host range expansion is that it doesn't require any new adaptations. The insect already has all the adaptations necessary to use that new plant. So let's use the black swallowtail as an example. It, of course, is a specialist on plants in the carrot family, plants like golden Alexander. So it's got all the adaptations to eat plants in the carrot family. So when we imported Queen Anne's lace and carrots and dill and parsley, all members of the carrot family, the black swallowtails already had the adaptations necessary to start using it. So it did not require adaptation, did not require evolution to accept this as a host plant. They already had those adaptations ready to go. And if you look at, let's say we were to take away the native plants and only have the non-native plants, you would have a 90% reduction in the insects that eat plants. So even though host range expansion does occur, it's not going to save the day if we lose our native plants. Why do insects fly towards light? That question has been asked for the last 100 years at least, and it turns out that one of the earliest hypotheses is the correct one. There's something called the dorsal light response. Insects always fly so that the light source is coming down and hitting them on their back. And that's because the light always does that. It's never coming up from the bottom. The sun never shines from underneath, and neither does the moon. So when you're orienting to sunlight or moonlight, it's very easy to fly and have that light hit your back. But if there's an artificial light source, that's a very small pinpoint of light compared to the sun or the moon. And the insects do the same thing. They fly so that the light is always hitting their back. But that means they have to go in a circle around this light source, and they go around, 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 and finally just bang into it. And we can use this knowledge to address a really serious problem, and that is light pollution. Light pollution is one of the major causes of insect declines in our current human-dominated landscapes. And these are all the ways that lights are killing insects. And we got a lot of lights out there. So it's a major, major environmental problem, but it has a really simple solution. The light that our nocturnal insects are responding to is light that comes from the moon, and it is largely in the UV spectrum. And it turns out we are lucky that if we use lights that are not in the UV spectrum, the ones that are emitting yellow light instead of cool blue wavelengths, nocturnal insects are not attracted to it. So simply by switching out our light bulbs from white to yellow bulbs, we could save millions of insects every night. And a recent study came out showing that yellow LEDs are even less attractive to nocturnal insects. So if you use a yellow LED, you're actually saving millions of dollars as well. Okay, Lyme disease, huge problem over much of the country, and I get a lot of questions about it. Like this one. I live in an area with lots of Lyme disease. Several websites suggest keeping large lawns because they're not attractive to ticks. The sites also say you should get rid of brush piles because ticks love them. So how can I contribute to local ecosystems without getting Lyme disease? Let's think about what deer ticks, the ones that transmit Lyme disease, actually need to survive in our landscapes. Deer ticks don't eat native plants. They don't eat leaf litter, and they don't eat brush pile. They eat blood. So what they need are mammalian hosts, and those hosts are small rodents and deer. The reason we have Lyme disease now is because we have way too many deer. There's deer overabundance, and Lyme disease was not around that anybody in any way that we could detect before deer exploded and got to be densities way over the carrying capacity. So a good way to reduce the infectivity rates of Lyme disease is to increase the diversity of alternative hosts in your landscape. This is research coming out of the Carey Institute in New York. So in other words, if you increase the mammal diversity on your property, so add skunks, add chipmunks, add possums, add squirrels and bunnies and raccoons and groundhogs, weasels, foxes. All of these guys are alternative hosts, but they're not very good hosts. So often the Borrelia, the disease organism, dies within those hosts. They're dead-end hosts, so they don't transmit the disease. And when you have a diversity of alternative hosts on your property, the chances that a tick that's actually infected will pass the disease on to you drops dramatically. And there's a really good natural experiment that has occurred to demonstrate this. In the southern states of the U.S., there are lots of deer, and there's lots of deer ticks, but there's very little Lyme disease. Why is that? Because they have lizards. They've got several species of anoles, they've got skinks, and they're dead-end hosts. So when the ticks bite these organisms, it ends the disease cycle, and infectivity rates drop a lot. Let's also think about how you get a tick. Ticks don't run after you. They find a plant, usually crawl up on it, put out their little legs. It's called questing, and when you walk by, they grab on. So the websites are correct that there's not very many ticks in your lawn, particularly if you keep it mowed and manicured. So in the spring, when infectivity rates are high, so May and June, stick to the mowed parts of your lawn. You don't need acres and acres of lawn. You just need to not brush up against your vegetation. But if you design a landscape like this with swaths of lawn, you can add a lot of vegetation to your yard, and accomplish many of the things that I talk about all the time. That shrinks the lawn. It will manage the watershed much more productively. Because you have less lawn and you've got more plants, you're sequestering carbon. You're helping pollinators, you're supporting the food web, you're favoring native plants, and you're also avoiding those ticks. Plants and animals have always moved around the planet, so the arrival of new species at our shores is a natural process. So, what's the big deal? If the new species are more fit than the species already here, then they deserve to replace them. I get that question quite a bit, and there's actually two questions here. What is the big deal about new species entering our ecosystems? And are new species more fit? Well, the big deal is the rate at which these species are entering our ecosystems. We are bringing species to our shores thousands of times faster than they ever arrived in the past, and thousands of times faster than the species within our ecosystems can adapt to them. So it's the rate at which we're introducing new species that is the problem here. Are these new species more fit? No, they're not more fit. They're simply here without their natural enemies. Now, we used to think they were more fit because they did seem to take over very quickly. So, for example, this is White Clay Creek State Park near me in Pennsylvania. And I took this picture in March when species from Asia leaf out before species from North America. So, every bit of green you see there is an invasive plant from Asia. This is a natural area. So you say, well, oh, these plants are great. They're displacing the native plants. Well, the reason they're displacing the native plants is because they're here without their natural enemies, particularly the vertebrates that would keep them in control. So not only are there very few insects or diseases controlling them, but the deer don't like them. So the deer eat our native plants. They don't eat the invasive plants. These are generalities, but for the most part, they don't eat the invasive plants, and that tips the competitive balance against our native plants. When the deer eat the little oak trees and everything else, but don't touch the invasives, all you're left with is the invasives, and that's why invasive species have exploded at the same time that the deer populations have exploded. Is it possible to kill woody invasives without herbicides? Yes, it is. This is Amur honeysuckle. And this message is coming from Dennis Conover at University of Cincinnati, and he has found that you can kill particular woody invasives like Amur honeysuckle, like autumn olive, like burning bush, by sawing it off at the base, and then covering the square. Or covering the trunk with a square of black plastic, so maybe like a hefty um, garbage bag. Pin it down with garden stakes and then leave it for a year. And what you're doing is blocking any sunlight from reaching that stump, and that will eventually kill the plant. So this works well on plants that are not stoloniferous. They're not going to send a shoot out to the side like Ailanthus will, or like Japanese knotweed will. But other invasives can be controlled this way. After that year, you want to go back and collect all your plastic, so you haven't loaded the landscape with plastic. But it does work if you don't want to use insecticide. Or herbicide, I should say. What about the risk of bringing nature into our everyday spaces? Isn't interacting with nature dangerous? Well, it used to be dangerous. Lions used to eat us, and water buffalo trample us, and crocodiles and hyenas. Africa was a dangerous place. And of course, we've internalized that. We're afraid of nature. But it's been a long time since I saw a lion on my property, so I'm not sure that is the case anymore. The real problem is our ability to assess risk is really, really poor. There is some risk associated with nature. So every year, about 2 people are killed by venomous snakes in North America. Not very many, but 2. West Nile virus kills around 130 people a year. But what is really killing us? Alcohol, 75,000 deaths. Sunbathing, melanoma, almost 8,000 deaths with 76,000 new cases every year. Car crashes, big one, 44,000. Collisions with deer, 440 deaths per year, 59,000 injuries. Dogs, our best friend, are killing 20 to 30 of us, falling 20,000. Overdose, of course, a big one, around 100,000 deaths a year. Texting, more than 3,000 deaths a year. Cruise ships, don't take a cruise. 20 people fall off cruise ships every year and drown. Autoerotic asphyxiation, whatever that is, 600 deaths a year. Hot dogs, 70 deaths a year. Lightning, 51. Vending machines, we pull vending machines over on us, kill 13 of us. Toasters, 370 people a year stick their fork in the toaster when it's plugged in. Flat screen TVs are falling off the wall and squashing us. And selfies are killing 29 people per year. So selfies are 14 times more deadly than venomous snakes. Bambi is 220 times more deadly than venomous snakes. And alcohol is 577 times more deadly than West Nile virus. Can you guess how many people were killed by native plant gardening last year? Not very many. Okay, here's a philosophical question. Should we kill invasive species? Do we have the ethical right to decide whether a plant lives or dies? It's a good question, good question. But I would pose that the people who are asking that question, whether we have the right to manage invasive species, are making decisions about what lives and dies every single day. So, for example, if you plant a plant like crepe myrtle that's not going to create any of the caterpillars that breeding birds need, you're determining whether that chickadee in your yard is going to starve to death because it doesn't have enough to feed its babies. When you have acres of lawn like this, you are deciding whether hundreds of species of plants could live in this space and the thousands of animal species that depend on that plant. They will all be eliminated by that lawn. When we hire mosquito fogger, we're sentencing not just 40% of the mosquitoes, but all the monarchs, the pollinators, the caterpillar bird food to deaths in our yard. So if we don't control invasives, we're gutting entire food webs. Do we have the right to do that? So I'll answer that question with a question on my own. Why do you only focus on moths? Aren't butterflies important too? No, they're not. And by important, I mean ecologically important. Butterflies are just bad-tasting day-flying moths. These are the butterflies here, the yellow branches. They come out in the middle of the moth lineage. Because they don't taste good, they're not important components of terrestrial food webs. It's the moths that are running those food webs. And for every species of butterfly, there's between 15 and 19 species of moths. So they are a lot more common. And they taste good for the most part, and that is what is fueling our food webs. Moths are transferring more energy from plants to other animals than any other type of plant eater. And that's why Dan Jansen calls them the meat and potatoes of terrestrial food webs. We really can't do without them. And besides that, I think moths are really cool. Some of them look like rhinoceroses, or they look like fish, and that has not been photoshopped. Or they look like rocket ships or stealth bombers or jet planes or lichens. Some of them look a lot like lichens. A lot of them look like bird poop. You know, if you look like bird poop, nothing's going to eat you. Many of them disguise themselves by gluing bits of the flowers that they're eating to their back. This is the camouflage looper. If you eat a conifer, you look like a conifer. There are actually two caterpillars in here. Or you can curl up inside the helianthus bud that or seed back that you've already eaten, look exactly like it. Many of them look like fallen leaves. This is one of the very best from Asia. Some of them look like seeds. Some of them look like seed pods. Many of them look like sticks, both as caterpillars and adults. Some of them look like broken sticks. Some of them look like clowns. Some of them look like they've got a false head with 2 eyes, or a false head with 4 eyes, or a false head with 6 eyes. Some of them have lightning logos on their sides. Some of them are huge. Many of them are really tiny. But many of them are just beautiful, both as caterpillars or as adults. Some of them have what we call the startle effect. They close their wings and then open them suddenly. It looks like an owl or something is staring at you. Some of them look just like wood chips, just little chips of wood. Some of them have 2 heads. Not really. A woman came up to me after I gave this talk once and said, "How do they have 2 heads?" That's actually a mating pair. They don't really have 2 heads. Many of the particularly sphinx moth caterpillars are really good snake mimics. Some of them look like bumblebees. Some of them look like yellow jackets. Some of them look like lightning bugs. Some of them look like jewels, and some of them look like that. So I just think they are really cool creatures. Do honeybees compete with native bees? This is a more and more common question with a very unpopular answer. So let's just look at the facts here. Honeybees are extreme generalists. So they can take the pollen and nectar from a number of different types of plants. The honeybee hives are large. 30,000 bees can be housed by a single hive, and they can forage up to 2 miles from that hive. So a single hive can potentially compete with native bees over 8,000 acres of land. Beekeepers supplement their hives with sugar. So when the density of flowers is very low in the landscape, they're supplementing their hives so that the number of bees in that hive always stay very high. As of April 2022, there were 2.92 million hives in the U.S. So honeybees, at that point, had saturated the continental U.S. 11.5 times. Now, if we assume native bee populations are near their carrying capacity, in other words, there's as many native bees out there as the environment can sustain, and then you add artificially a honeybee hive, a single honeybee hive, you're adding 30,000 bees to that area. There's no way you can do that without competing with the resources required by those native bees. And there are studies that are starting to support this logic. Um, Honeybees, when they were introduced to an island where they didn't exist before, it reduced nectar availability by 60%, pollen availability by 30%, and they reduced native bee populations by 80%. So this is the key figure here. There is a serious reduction in our native bees when we flood the environment with honeybees. Other honeybee people will ask, what about controlling privet? Privet it's a serious invasive species around the country, but when people want to control it, the honeybee people get upset because they say privet flowers are good sources of honey and pollen for honeybees. And if we remove privet, we're going to remove that natural resource and hurt the honeybees. Well, actually 9 species of privet that are highly invasive in this country, and they get big. This is me standing here. I don't know if that's 1 bush or 2 or 3, but when you have a privet bush there, you have nothing else. And privet has covered a lot of area. Over 1 million acres are covered by privet in Alabama alone. So there's a lot of privet out there. Now, privet blooms about 1 week per year. And during that week, yes, there's a lot for honeybees and native bees to use. The problem is the other 51 weeks of the year, it looks like this. There's no resource at all, and it excludes any other plant out there. So you're trading 1 week of resources and losing 51 weeks of resources. So there's no way that privet actually helps honeybees. Our oaks are dying right and left. When we cut them down, should we remove the wood from our property uh, in order to prevent transmission of diseases to healthy oaks, or can we let the wood stay there? It's a good question. We've got sudden oak death syndrome, we've got bacterial leaf scorch, we've got oak wilt, and many of our oaks are dying. But the transmission of those diseases happens when the oak is still alive. When it's dead, there's no more vascular system and insects cannot transmit the disease. So I would encourage you to leave the wood on your property if you can. We call it coarse woody debris, and there's a lot of biodiversity that depends on woody debris. So let's start small, things like columbolans. They're there by the millions. Little springtails. And then the things that eat those columbolans are there very commonly too. Things like centipedes, millipedes are eating the fungus on that tree. A number of beetles breed in dead wood, like click beetles and fire color beetles, and many species of scarabs are breeding in dead wood. Cerambycid longhorn beetles and their larvae that are called flat-headed borers. Lucanid stag beetles all breed in dead wood. So do basalid vest beetles, crested metallic wood boring beetles. And then, of course, the cracks and crevices in a dead log are also places where the few butterflies that overwinter as adults can hide. Things like mourning cloaks, commas, question marks use that woody debris to make it through the winter. And don't forget the carpenter bees. We have problems from carpenter bees in our houses because we've taken away all the wood that they used to use. If we keep some of that on our properties, that's where the carpenter bees will go. And don't forget about carpenter ants. Carpenter ants, by the way, don't eat wood. They're not like termites. They simply hollow it out and live in it. And the reason we want carpenter ants is because that is what our big woodpeckers rear their young on. Pileated woodpeckers in particular will rear their young almost exclusively on carpenter ants. So if you don't have carpenter ants, you don't have pileated woodpeckers. And you won't have carpenter ants unless you have the wood that makes those carpenter ants. Is rearing monarchs good or bad? Well, it depends on your intentions. And there are two basic reasons that people rear monarchs. One is for fun and educational purposes, and the other is for conservation. I think there's a lot of pluses to rearing monarchs for fun, particularly for the little folks. It could be their first interaction with an insect, so they learn, hey, they're not all bad. They learn about complete metamorphosis, egg, larva, pupa, and adult. They learn about host plant specialization. Any third grader can tell you you're not going to have monarchs unless you have milkweed. That is host plant specialization. And maybe they pass that on to their parents as well. When you're rearing for conservation, though, it's difficult to do that without crowding them, and that is often a recipe for disease transmission. The big problem with rearing for conservation is that people, their hearts are in the right place, but they don't know how to do it. They often let the milkweed leaf material get too old, so the monarchs that come out are smaller than they should be. And again, disease transmission is hard to avoid when you crowd them. You're also rearing them indoors, and it removes the monarchs from the filter of natural selection that would occur outdoors. So there's at least theoretically possible that the monarchs you're releasing are genetically inferior to ones that have been filtered by natural selection. The recovery rate of reared monarchs is about 40% lower than when the monarchs are reared in the wild. So it suggests there are problems with rearing monarchs if you're doing it for conservation. The best way to help monarchs is to let them rear themselves. Give them enough milkweed, a large milkweed patch in your yard, and the monarchs will do their thing. Yes, there's a lot of mortality, but that's that filter of natural selection that we're talking about. There's one important caveat, and that is the European paper wasp. This is an invasive species that eats caterpillars, including monarchs. And if you have European paper wasps, as several places in the Midwest do, then bringing them inside makes a little bit more sense because these guys do eat a lot of monarch caterpillars. Speaking of monarchs, the monarchs on my milkweed keep disappearing. Just when they get big, they disappear. And this is true. I get this question for black swallowtail, for pipevine swallowtail. I assume birds are eating them, but I thought the monarch caterpillars tasted bad, so I'm confused. Who is stealing my monarchs, or what is stealing my monarchs? Nothing is stealing your monarchs. Your monarchs are crawling away from the milkweed before they form their chrysalis. Butterflies want to get as far away from their host plant as they can because it's the natural enemies seek out the host plant to find the monarchs. So here's one in my backyard. It was on a grass stem. Here's a pipevine swallowtail chrysalis, also on grass. I found a pipevine swallowtail chrysalis on the lower part of a picture frame in my living room. It had crawled right in our sliding glass door and up the living room wall, and there's a predator-free space. That was about 25 yards from our pipevine. So they do move a good distance to get away from their natural enemies. Excuse me. So the bottom line is that nothing's taking your monarchs or your other butterflies. They're simply forming their chrysalis where you're not looking. Could you provide your thoughts on the use of southern, more heat-tolerant species within more northern parts of the U.S.? Yes, that's called assisted migration. It's controversial. I'm not a fan, and this is why. So this is what climate systems used to do before we had climate change. This is the jet stream, and it used to go across the country like this. It would wobble a little bit, but generally above it, it was colder, and below it, it was warmer. With climate change, this is what we're getting, particularly in the wintertime. We're getting wild swings of the jet stream. So when it goes way far north, it's warmer than it ought to be way up here. But when it goes far south, it's colder than it ought to be way down here. Remember, last winter, there were 9 inches of snow in Baton Rouge, Louisiana, and it got down to 9 degrees. Even some of our native plants were killed. So if you start taking these southern plants and moving them up here, anticipating a gradually warming climate, these polar vortices that keep coming every winter are going to kill them. Another big problem is, though, you're moving the plants away from the plants and animals they co-evolved with. Remember, a major Ecological responsibility of plants is to support the food web, to transfer energy they've captured from the sun to other organisms. And if you move them away from the organisms that can eat them, primarily the insects, then they're not going to do that anymore. So that's a big concern as well. What do you think of no mow May? Well, I think it's a good intention, but it ecologically makes no sense at all. This is what it looks like when you don't mow your lawn. You get tall, cool season European grass, which is not going to support pollinators any better than short your cool season European grasses. If you have a terrible lawn and you've got dandelions and dead nettle and clover and other blooming things in your lawn, there will be resources for your lawn during May, or for pollinators during May. But pollinators need resources all summer long, not just in May. So then in June, you come and mow it, and you pull the rug out from all of those bees that they started to build their colonies off of. So the best alternative, I think, is to, instead of have no mow May, have no mow areas that you never mow, and that's called a pollinator garden. And the trick is to get a sequence of bloom all season long, from April all the way through the end of October, and that requires different plants that are going to bloom at different times of the year. So if you have a big restoration like this, you're meeting the needs of lots of species of bees, and it's much easier to get a sequence of bloom because you can use all different species of plants. But you can do it on a smaller level as well. This is just an idea. I know a lot of these are non-native, but it gives you an idea. But right in the middle of your lawn, you can create a pollinator garden. I often find the expense of purchasing native plants is out of my budget. Do you have any suggestions? Well, Rick Dark has a suggestion. He says try addition by subtraction. So you're not actually adding native plants. You're simply removing the non-natives that you don't want. This is what my yard looked like at one point a few years ago. I did plant the Ilex verticillata, and I planted the oak as an acorn. But the milkweeds, the goldenrod, the native grasses, all of these asters here, they all came in on their own. I didn't plant any of those. But we did have to monitor when an autumn olive came in, or a burning bush, or anything that we didn't want. So by removing the non-natives and simply letting the natives or the natural systems bring in seeds, you can restore an ecosystem with very little cost. What's bringing in the seeds? It's all of our creatures, things like red squirrels and gray squirrels and chipmunks and blue jays, and ants are actually moving a lot of seeds, particularly of spring ephemerals. This is a bloodroot seed, and it's got a structure on it called an eliosome. Eliosomes evolved so that ants will move them around. Ants love to eat eliosomes, so they pick up the seed, they carry it back to the nest. It could be 3-4 feet from the original plant. Then they eat the eliosome. They can't eat the seed, so they put it in the garbage dump of the ant nest, which is about an inch below the surface of the soil, and it's a perfect place for this plant to germinate. And that's how spring ephemeral seeds get around. But you have to be vigilant when the little burning bush or the popcorn tree or many of the other invasives pop up. That's when you have to get rid of them. That's really easy when they're little. You get your little whacker there, just one swipe, and it's gone. If you wait till they're full-fledged bushes, then it certainly is much harder. Do you have a succinct statement to submit to my HOA who recently cited me for growing weeds? Well, you remind them that a weed is a plant out of place, and our native plants have been here millions of years. They're not out of place. But I have lots of statements. I don't know if they're succinct, but you could try this. We humans face life-threatening crises from climate change and biodiversity loss. Reducing the area of lawn and using more productive native plants in our landscapes addresses both of these crises. This can be done tastefully, without the use of chemicals, and without reducing property values. It is the future of landscaping. I'd be interested to know whether that actually works on any HOA. Back to HOAs, my HOA believes that native plantings reduce property values. How can I convince them otherwise? By giving them a landscape that they can't refuse, as it were. A lot of people think native plant landscaping is inherently messy. So show them you can use native plants in formal designs. This is a Linn O'Shaughnessy design taken by a drone 400 feet up. You don't get more formal than that, and every plant in that landscape is a native plant. Formality is a function of the design. It is not a function of the plants in that design. And I can say that because our native plants are used in formal designs in Europe every day, and they love them over there. This is an all non-native landscape. This is Norway maple. Those are Asian azaleas. That's English ivy. This is pachysandra, and of course the lawn. But it's a mess. It's a mess because it has not been maintained. So really, when HOAs are complaining about landscaping, they're complaining about the maintenance levels. This is Pam Carlson's landscape in Chicago. It's all native except for the grass here, is maintained, it's beautiful, and there's no HOA that would throw Pam out because she has a landscape like this. So provide a good model for your HOA and convince them that, you can use natives productively and without reducing property values. I have a small property. Should I plant several individuals of a few species, or should I try to squeeze as much diversity onto the property as possible, but only have one or two individuals of each species? Another good question. We all hear that diversity is good, but when you're essentially performing a restoration, it depends on what it is you're trying to manage your landscape for. Let's say we're managing for monarchs, and you plant one or two rammets of milkweed. That's not enough because the monarch will come and lay an egg on it. She'll look around for other milkweeds. There's nothing there, so she'll lay another egg on it. You get 2 or 3 eggs on a little planting like this, and the caterpillars, particularly in the fifth instar, will strip this, and then people get upset, and the caterpillar stars. They say, "Oh, it's gonna kill my milkweed." It's not gonna kill your milkweed. It'll come up from the rootstock, but what you really need for monarchs is a milkweed patch. You need something like this, and then there's enough for everybody. The monarchs and the milkweed tussock moths and the milkweed bugs and beetles, no competition at all. So again, depends on what it is you're trying to manage. If you're managing for pollinators, massing the blooms of particular plants is a good idea because it minimizes the energy that bees have to use to get from flower to flower. But you're right. Most people do not have properties that are big enough to manage for everything. So this is a good time to get to know your neighbors. Here's a brand new neighborhood. They could easily divide up ecological responsibilities. This guy's going to have the pollinator garden. This guy's going to put in a couple of oak trees. You can divvy up these goals. This guy's going to have the water feature. It's a good way to get to know your neighbors, and you also can increase the diversity of the plants you're getting on your properties, uh, because now you have a bigger property to deal with when you're combining your neighbors. Okay, how can I convince my neighbor to stop mosquito spraying? This is a huge problem around the country. I'm getting this question almost every day. And a woman came up to me not long ago and she said she actually did this. She went next door to her neighbor and she said, "What are you afraid of? Why are you fogging for mosquitoes?" And they said, "Well, we don't want our kids to get a mosquito-borne disease." So I looked in statistics of how many kids were actually killed by a mosquito-borne disease between 1999 and 2007. It was 0.037 deaths per year. In comparison, over 8,000 kids died in car crashes during that same time period. So that shows you how these two risks relate to each other. 73.2 million kids under the age of 16 in the U.S. So each year, your child has about a 1 in 197 million chance of dying from a mosquito-borne disease. It's not zero, but it's about 3 times more likely that you're going to win the lottery than die from a mosquito-borne disease. The next thing you can do is explain the ecological costs of fogging. A lot of mosquito companies say it's a natural organic product and it only kills mosquitoes, so why not hire them? Well, that's not true. I mean, it kills all the insects it comes in contact with, including our monarchs, including our pollinators, including our natural enemies. We hear this, but I actually have an undergrad doing a study this summer to confirm it, looking at non-target impacts of mosquito fogging. We bought a mosquito fogger and we're doing it. It does. Kills everything within 24 hours, and not when you spray them, but when they sit on vegetation that was sprayed. This is a sign that you can actually get that might inform your neighbor. No mosquito means no fireflies, no ladybugs, no butterflies, pollinators, hummingbirds, songbirds. Are you sure you want that? Most people don't know what the consequences of fogging for mosquitoes are. And then you can also give them alternatives. Tell them about mosquito dunks. Tell them about, the mosquitoes are not going to fly into directed breeze. So just get that fan on your back porch and maybe they will change their mind. Why do you want us to keep leaves on our property? Another very common question. There's 4 reasons. Leaves protect it's a blanket on your soil, protects the soil moisture. Everything that lives in the soil requires high moisture levels. It prevents soil erosion, returns nutrients to the soil, and provides habitat. The soil harbors more species underground than above ground, and they all, again, need high moisture, and that includes the mycorrhizal fungal associations that are transferring nutrients to the roots of your tree. This is an oak tree, by the way, and I just stopped along the side of the road and took this picture. Nobody planted this, but these delicate ferns have gotten through normal layers of leaf litter, no problem at all. In 1 square meter of leaf litter, there are 250,000 mites on average, 100,000 springtails, 90,000 proturans, those are primitive insects, 1,000,000 nematodes, and all these guys are breaking down the leaves, returning the nutrients that your tree used that day, that year, to the soil so that it gets to use them again. When you rake your leaves away, you're starving your tree over the years. And there are beautiful things that use those leaves, like the banded hair streak. The caterpillars eat this stuff, dead oak leaves. 70 species of litter moths, like the ambiguous litter moth, the American Idita, the dark-spotted Palthus, and 67 other species are developing as caterpillars on leaf litter. And then, of course, you have the predators that are eating all of those caterpillars, including lightning bugs, fireflies. They're not bugs, they're not flies, they're beetles. This is what the adult looks like. We all know that, but that's what a firefly larva looks like. It is a predator in leaf litter. And when you rake away your leaf litter, you lose your fireflies. And of course, the birds know that, and they're hunting in leaf litter all the time. What should you do with your leaves? Well, put them in your flower beds. This is a house down the street that does that. It's not an all native landscape by any stretch, but it does give you an idea where you can put your leaves. My son bought a house a few years ago, and he called me up in the fall, and he said, "Dad, I've got too many leaves. What should I do with my leaves?" I said, "Put them in your flower beds." He said, "I don't have enough flower beds." I said, "Exactly. That is the way you reduce your lawn. You increase the number and size of your flower beds and put your leaves in there. But won't those leaves kill my plants?" Who was raking the leaves before we got here? And there were plants in North America. I read about it. They get through those leaf litter without any trouble at all. This is wood poppies coming up in my yard right through the leaves, and here they are a few days later. Violets, very delicate violets coming up, no problem. So our plants are much better at getting through normal layers of leaf litter than we give them credit for. Can I mulch my leaves? Well, you can, but when you do that, you're grinding up anything that's in those leaves. There is a cocoon of a beautiful moth called the dot line white in this leaf litter. It's right there, but you never would see it when you're raking those leaves. There it is up close, and there's the beautiful moth that you would kill by running it through your lawnmower. I know caterpillars are important for birds. I've been talking about that for a long time now. How can I increase caterpillar production on my property? Well, first you have to use the plants that make those caterpillars. Again, I've talked about this 100 times. You folks all know this. Go to your Native Plant Finder, National Wildlife Federation website, and it will put in your zip code in the ranked list of the most important plants for your county. Most important woody plants and herbaceous plants will pop up. So now we know what plants we should be using on our properties. But we also have to landscape under those plants in a way that allows the caterpillars those plants produce to complete their development. This is fairly new. So what happens to caterpillars after they have eaten their full? 94% of them drop from the tree, and they wiggle their way beneath the soil surface, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. There is no leaf litter under the tree. It's messy. We don't tolerate it. And we mow and compact the area under the tree so that it's rock hard. Very difficult for those caterpillars to get to safety, particularly during the summertime. So this is what we're trying to do. We're trying to build what Heather Holm calls soft landing, and it's not really about landing on vegetation. It's about creating areas under your trees where the soil is not compacted and where you're not going to walk and where you're not going to mow. When you have a landscape like this, it's pretty, but you've got grass right up to the tree. And when the caterpillar drops down, it's got to get to safety through that grass. And we're talking about 81% east of the Mississippi. 81% of the land under our suburban trees is either lawn or pavement. So that's what caterpillars have to contend with. And when it's lawn, they have a lot of trouble getting through the thatch. This is work by my student Emma Jonas. So they pupate essentially right at the surface. This is a centimeter. It's half a centimeter below the surface of the. It's really in the thatch of the grass. When you have leaves or mulch, they can get 4 or 5 centimeters under there, and it's a much safer place to be. So what happens when they're right near the surface? Well, we walk under there with our feet and our mowers, and we squish them. A single footfall gives enough pressure to squish a pupa 44% of the time, and a single pass with a mower kills them 46% of the time. Dangerous place to be when you pupate near the surface. So what we need to do is create no-go zones where we're never walking, we're never mowing. That's where you can do your fancy spring ephemeral gardening. And of course, that helps you reduce the lawn, and it is beneficial to the tree as well. You can use native ground covers like wild ginger, like Virginia creeper, good ground cover, mayapple, foam flower. There's lots of options here to create beautiful landscapes. If you can see the ground, you don't have enough plants. That's called green mulch, and that should be your goal. Who's going to argue with a landscape like this? Caterpillars, believe it or not, like to get underneath things like rocks. If you have a few rocks in your garden, they will crawl under the rock, and it's a safe place to pupate. And there are several species of caterpillars that need wood. They actually tunnel within downwood to pupate in it. So logs like this, if you can add that to your garden as a feature, it helps a number of species of caterpillars. Things like robin's carpenter worm, the leopard moth, those are both on oaks, the pearly wood nymph and the beautiful wood nymph. That's what the caterpillar looks like, and here it is burrowing right into my back porch, actually. The 8-spotted forester moth, another pretty caterpillar. Harris's 3-spot, burrowing right in again. There it goes. It ejects a little ball of sawdust, but you wouldn't think caterpillars are able to do that, but they do that, which means they need the wood to do it in. That includes the green marvel and its caterpillar. There are a lot of species that do that. Do cultivars of native plants have the same ecological value of their parent species? This used to be one of the most common questions I got, because when you go to the nursery and you try to buy a native plant, it's typically a cultivar. And the answer is it depends on what the cultivar trait is that created the cultivar. So first of all, many cultivars are actually varieties that were found in nature. They simply were brought in and somebody put a name on them. So it was nature that selected for that variant. And this is one of them. This is Phlox paniculated jenna. It was found in the mountains of Tennessee. It has twice the number of flowers as the straight species. And guess what? It supports twice the number of pollinators. We did a study looking at 6 traits of woody plants, 6 common cultivar traits, taking a tall plant, making it short, introducing disease resistance, taking a green leaf, making it red or purple, traits like that. And the only trait that consistently reduced insect use in a common garden experiment over 3 years was taking a green leaf and making it red or purple. That loads the leaf with anthocyanins, and that is a feeding deterrent. So I can say avoid red leaf cultivars. When you're talking about flowering plants, though, the news really isn't as good. When you fool with flower structure or color or size, you're messing up the relationship between the specialist pollinators and that plant. We've got almost 4,000 species of native bees in this country, and over a third of them are pollen specialists. They can only reproduce in the pollen of particular plants, and they have very specialized relationships with the flowers of those particular plants. This is bloodroot, and if you make it a double flower, you've changed the reproductive parts of the flower to petals. So it's beautiful. It's a great decoration, but it's not going to help pollinators at all. That's true for most of our hydrangeas as well. So avoid double flowers. There are generalities we can make like that. But in terms of most of the cultivars for flowers out there, go to the Mount Cuba Center website. They have been doing a number of trial garden comparisons between straight species and cultivars for several years now, and all the results are posted on this website. So you can see how your favorite cultivar is doing compared to the straight species on this website. Does urban restoration work? or are you encouraging ecological traps that will lure animals to their death? A really good question, and we need a lot more research to see what's going on. But the research that has been done is very encouraging. Emily Geist worked in Omaha, Nebraska, comparing monarch survivorship in suburban gardens versus the wild. And my student, Brian Cutting, did the same thing. And in both cases, they found survivorship was much higher in the suburban gardens than it was in nature. Very encouraging. Look at what our bluebird boxes have done for bluebirds. Bluebirds were in trouble not that long ago. We had lost the cavities. There were no more snags in people's yards. We had sparrows, house sparrows, and starlings kicking bluebirds out of their houses. But people got serious about putting up bluebird trails and bluebird houses everywhere. And now bluebirds are one of the most common bird species in our suburban neighborhoods. Big success there. A guy by the name of Benedict Schmidt in Switzerland was concerned. There were 10 species of amphibians in Argois, Switzerland, which is it's an urban center. All 10 species were in steep decline. So he dug ponds all over the city, and then he monitored what happened to those species. And 9 of the 10 species increased rapidly by breeding in those ponds. The 10th species did not because the ponds were too small for that particular species. But despite the traffic and the lights and all the other things in the cities, the amphibians responded. So with these studies, the news is good. It does seem to be working, but we do need more research. And finally, what gives you hope? How do you not become discouraged by the task at hand? Another good question. And, I'll admit, some days I do get a little discouraged, particularly when I listen to the news. But there are several reasons that I am hopeful. And one of them is that the biodiversity crisis is now part of the global discussion. It actually has been for several years now. The UN has met at least 3 times to talk about the biodiversity crisis. Most recently in May of this year, I believe. The only country not to attend that meeting was the US, but the rest of the world's concerned about it, and that's good news. We're talking about it. What's really encouraging me, though, is the public's reaction. They're starting to recognize that as individuals, they are not powerless when it comes to conservation. An individual can reduce the size of the lawn on their property. They can use keystone plants, the ones that are supporting the most biodiversity. They can change their light bulbs. They can fire Mosquito Joe. We can do soft landings. We can put beds under our trees, help those caterpillars that are up in the trees. We can add pollinator gardens. People are recognizing this. We can remove the invasive plants on our property. Municipalities are actually paying people. There's financial incentives to restoring our landscapes. Minnesota's been doing that for several years now. They've got a cost-sharing program encouraging homeowners to reduce or replace their lawn with appropriate Minnesota prairie plants. It's very popular. Some states are banning the sale of invasive plants. Delaware has banned the sale of 37 species of invasive plants. Other states are doing it piecemeal, but it's starting to happen in a number of places. HOAs are realizing that we can make beautiful landscapes with native plants, and it doesn't reduce property values. We're making progress in agriculture as well, which is really important because almost half of the country is in some form of agriculture. When we invented Roundup Ready corn and soybeans, we said, oh, let's just spray right up to the road and replace it with lawn. Looks nice. But boy, that devastated monarch habitat and native bee habitat and replaced it with a plant we now have to mow. But we can reverse that. We can put the prairie plants back on tens of thousands of road verges through the agriculture of the Midwest, right through the East, and farmers are starting to do that. Prairie strips are becoming popular. You put the pollinator strip right through the corn, right through the soybeans. Not only does it help local pollinators, but you do it perpendicular to the flow of water off the property, and it intercepts topsoil and intercepts the nutrients before it gets into the Mississippi watershed. Again, very effective form of conservation, and is supported by CRP funding. But what's really encouraged me is the speed with which all of these changes are happening. Aldo Leopold, when he said a number of wonderful things, but one of the things he said is that one of the penalties of an ecological education is that one lives alone in a world of wounds. Well, that was back in the 40s. You're no longer alone, folks. You are no longer alone everywhere. People are starting to heal the wounds, particularly on their little piece of the earth, their property. Robert Swan recently said the greatest threat to our planet is believing that someone else will save it. It's not going to be someone else. It's going to be you. It's going to be you. Your neighbors, I'll help a little bit, but it's really going to be you. And that's because you are nature's best hope. Thanks very much. The websites, particularly the one from Mount Cuba Center, is right there if you want to write that down.
Thanks so much, Doug, for this thought provoking presentation. I know I certainly didn't get enough, so let's jump into a few more questions from our webinar registrants. Our first question is about local genotype. Are mail order plugs okay for genetic integrity, or should I stick to local ecoregion sources?
Right, it depends on where you live. If you're close to the source of the plants that you get by mail order, then you have no problem. But uh, it is it's a good goal is to try to get local ecotypes. And you can look at the big seed producers or plug producers and ask them where their seed sources come from, because a lot of times they will designate which part of the country they got the stock from. But it is a good goal to try to be as local as possible. Um, not not so much from the point of view of the insects that are gonna use those plants, but from the plant itself. It's if it's a local genotype, it's adapted to the conditions of where you live, your latitude, your altitude, your soil type. So your chances that that plant will thrive are much greater.
We had a lot of people with questions about potential insect and rodent issues related to native plantings. Jeff asked, do mass producing trees such as oaks and hickories increase rodent issues near homes?
Yes. Um, yeah, it's part of the natural cycle, but of course, the more rodents you have, the more rodent predators you have, the more hawks you have, that's foxes and black snakes and all the other things that are making the world go round, do very well. So rodents are an essential part of our terrestrial food webs, but they do cycle, and they do cycle largely because of oak masts.
Wildlands members include a lot of people without yards. It's sometimes hard to expand the conversation beyond suburban homeowners, but Christine asks, can window boxes meaningfully support specialist bees?
Absolutely, absolutely, and we recognize that at Homegrown National Park. We created a resource on our website, homegrownnationalpark.org. You go there, and it will tell you the best native plants, for containers. Not all plants do well in containers, but it'll tell you the best ones for containers in each ecoregion of the country at ecoregion level 2. It's a great resource. You can see which plants are going to do well where you are, and you can put them on your window boxes, on your balcony, your front porch. Because you're right, a lot of people who live in cities don't have the land to do this. But most people do have access to, at least a window box, and you put that flowering plant in there, the specialist bees will find it, the migrating monarch will find it, the generalist bees will find it. There are a lot of species of bees that live in our urban areas, and, they're not supported nearly as well as they could be if everybody turned that pile of bricks that we call an apartment building into a really valuable resource with, um, container gardening on balconies and front porches.
Our last question is asking for those next steps. How can ordinary people support native plant movement beyond planting?
Well, that's a really good question. You're really talking about changing policy that supports these types of plantings. So, for example, how are the roadsides managed in your township? Are they mowed by the calendar essentially for no reason? You mowing a roadside once a year makes ecological sense. It makes safety sense, but the rest of it doesn't. So maybe you can encourage more ecologically sound mowing practices. And the way you make these changes is to make it clear, not just you, but everybody, make it clear to your mayor that these are important issues. The environment is important to you, even if it's not on the top 10 list of our the things we worry about during an election year. It's important to you, and you're not gonna vote for him if he doesn't support these important actions. Encourage the bounty on non-native plants. So St. Louis did that. Fayetteville, Arkansas did that with calorie pair. If you get rid of a calorie pair, you get a free tree replacement. North Carolina has done that as well. So these types of things, any kind of incentive will help move this culture change that we're talking about along. The lawn reduction programs in California, they get $3 per square foot rebate for every square foot of lawn they remove and replace with a xeric planting. What that does is it makes it culturally acceptable to start landscaping in an ecologically sensitive way. So if your neighbors say, "What are you doing?" Say, "Hey, I'm getting paid to do this. This is your top-down support from local policy." So change those policies. Join your HOA if they're giving you issues. Educate them from within, and that's how we make bigger changes.
Thank you so much, Doug, for joining us tonight. On behalf of Wild Ones, thank you for being part of this conversation and for everything you do to support native plants and natural landscapes. We look forward to seeing you again soon.